So how are we going to actually mathematically attack these things? And the simplest way is to use a moving average, and we'll talk about what that means in the next slide, or use exponential smoothing. And that's what you'll do on the homework, and that's what you'll have as a test problem on the test. You can also estimate the trends using complex moving average and exponential smoothing, which we don't discuss in this class. If you have a trend in your data, you really need to be using time series analysis, which is beyond the scope. And same with seasonal variations and cyclical variations, okay? So if your data just has some serious cycles or trends, you need to use a time series approach, something like a autoregressive moving average model once the trend is removed. So a moving average is real simple. We just look at our historic data, and then we take an average of the last n periods, and that's our forecast going forward. So if I'm doing a 4-period moving average with monthly time series, I would just look at the last 4 months, average it, that's my forecast going forward. Simple as taking the last 4 observations, right? If I was doing a 5-period moving average, I'd take the last 5. And, moving averages, if you have a trend, are always going to lag the trend. Why? Well, if I'm linearly increasing, and I take the last 4 observations, what are those 4 observations going to be? They're going to be less than what you would expect the next observation to be, right? Like if you took a moving average and it was 1, 2, 3, 4, the average of 1, 2, 3, 4 is 2.5, right? 0, 1, 2, 3, 4 would be 3, right? And that would be less than what you would expect the next one to be, which would be 6. So when you have a trend, whoa, you guys are on camera. Sorry about that. When you have a trend, you're going to lag the trend with both exponential smoothing and moving average. And that's another test question that I like to ask. I tossed this slide in for fun. It has nothing to do with the course. That in stocks, people often talk about a moving average. I don't know if any of you follow the stock market, but they talk about a 200-day moving average, a 50-day moving average, and supposedly it means something. I have yet to determine what it means. So this was from Yahoo Finance of IBM's stock price from 2006, and I plotted the stock price, which goes up and down. And you can see the 50-day moving average sort of smooths out that trend, and that's in red. And in blue, or in green, the 200-day moving average even more smooths out it and gives you a more even forecast than the series itself. So moving average, the forecast for my next period, f of t, is 1 over n plus my observations from the previous t prior periods, or n prior periods. So the advantage is it's easy to use, it's easy to understand, and it's simple. Disadvantage is that it lags a trend and it's not a statistical measure. The other approach is exponential smoothing. And what I do is I take my old forecast and then I multiply that by 1 minus alpha. I think it's easier. Let me highlight this part of the equation. So if I take my old forecast, multiply by 1 minus alpha t, and then I add alpha, the current value. So if this, let's say alpha was 0.5, and I guessed that, or my forecast was 100, alpha is 0.5, and I observe a value of 90, okay? So my forecast for the period was 100. The actual in the period was 110. alpha 0.5, okay? What I would do is my forecast for the next period would be 100 times 0.5 plus 110 times 0.5. This is 1 minus alpha, and this is just alpha, and that would be 105. So you adjust your forecast based on your actual. And the alpha tells you how much you take from your forecast versus how much you take from your actual. These things are horrible markers. Okay. So the smoothing constants that most people would use in a business environment for alpha would range from 0.5 to 0.05, okay? Higher the smoothing constant, the more you take your last observation is important. Because if alpha is 1, your forecast is just whatever you observed last. If alpha is 0, it's your initial forecast when you started the whole process. So it can be changed to give more weight to the recent data when alpha is higher or more weight to the past data when alpha is low. And mean squared area and mean absolute deviation can be used to check smoothing constants. So let's assume that we have some data in Excel, and we're going to run exponential smoothing moving average on the data to get a forecast, and then compute mean squared error, mean absolute deviation. So I'm going to open up Excel here. So my demand looks like that, okay? And I'm just typing some values in. Now, if I did a moving average forecast, how would it, let's say it's a 3-period moving average. Well, I can't take a moving average for the first 3 periods of 3 periods, so I'm just going to do, I'll just put 3 there. So if I was forecasting the 4th period, how would I do, what would be the moving average forecast? What would I do? I'd take the average of the 3 prior periods, right? And I can fill that down. And so if I had to guess, let me make this a little clearer. If we were at the end of week 6 and I said, what do you think week 7, how much are you going to sell? And if I said the model was moving average 3, you would say 103 units. Or 103.3 units, okay? Make sense to everybody. Now, exponential smoothing, and let's say alpha equals 0.5, you need an initial forecast, okay? And so let's say our initial forecast was 120. So I take my 120 times 0.5 plus my actual times 0.5, and that gives me my first forecast, okay? Now the next period, I would take my forecast value times 0.5 plus my demand times 0.5, and this would be and I got my, messed up. Should be B2, my demand from my prior period. It's embarrassing. And so now my forecast is 101. Now let's do a smaller alpha, 0.25. So I would take 75%, 1 minus alpha from my forecast, and then 25% from my actual, And so it reacts slower than before. Now the question is, what method's best, right? Is alpha 0.5 best or alpha... And I got rid of alpha 0.5. That's not good. So I'm going to have to put back this to alpha 0.5. Sorry. 0.5, 0.5, and then 0.5. Now I can ask the question, which one of these is better, to have the smoothing constant of 0.5 or 0.25? And to do that, I would need to compute the error of both. So error 0.5, error 0.25, right? And what is the error? Well, the error is just the difference between the forecast and the actual. The forecast and the actual. And the...
Does it say, are your formulas correct in there?
No, this one is...
Yeah, I went to C instead of B.
This one should be just 120. 120. I messed that up. Okay. So you can compute the difference between the forecast and actual, how far off you are, right? And you can take the absolute value of that. And the absolute value of the error and that would be yes of that number and obviously we don't know the error for that last period because that's our forecast. Now let's make sure we did this right. Our initial forecast in both cases for week 1 was 120. Take 75% of that initial forecast with the smoothing constant of 0.25 and take the demand, which would be B2. That's bad. D2, B2. Okay, that one at least is right. Okay, so we've taken the absolute value of the error, and so our MAD would be just the average of those. So on average, when we use a smoothing constant of 0.5, we have an average error of about 21. And when we use a smoothing constant of 0.25, we have an average error of 19 in this data set, okay? So you're a little better using the 0.25 in this data. And so to evaluate your forecast, all you have to do is take the forecast minus the actual, take the absolute value of that, and compute an average difference. That's the easiest way. Or you could just take the sum of squares error of those two, okay? Everybody has had statistics. This is not a statistics course, but that shouldn't be too challenging, right? So on the homework, you're going to work exponential smoothing, moving average problem in Excel. Be prepared to do one on the test. And my favorite test question is to compare it to a naive forecast. About 2/3 of the time, the naive forecast is going to be better when I make the test. Just because sometimes some things are just random and there's no pattern. And if it's just random, you want to, what? Just guess the long-term average or the initial forecast, assuming it was correct. So, when you get to time series, and this is well beyond the course, but there is a concept of whether or not short-term events have a long-term impact, okay? And x of t equals x of t minus 1 plus 2. plus error versus x of t equals 2t plus error. These functions have the exact same mean, right? Because the expected value is always add 2. But in the first case, you always remember what your last error was. An error is just, let's assume, mean 0 with some standard deviation around it, okay? And what happens is that one where you forget what happened last week, you forget that error, it has no impact going forward, is going to be fairly narrow, just goes up, okay? When you remember your error, you're going to get what they call a random walk with drift. And you're going to get a very divergent series, okay? And obviously this is not on the test, but it matters a lot what model you choose when you're forecasting out time series a significant way. So to review, mean squared error and mean absolute deviation. Mean squared error is you find the error forecast minus the actual, and then you sum those up and divide by n. Mean squared error, you sum the square of the errors and divide by n. Now the book talks about the concept of double exponential smoothing when you have a trend. And seasonal methods are in the book. They're not going to be on the test. You should be using time series methods in that time. Look it up on Wikipedia if you ever need to use it, right? And so those are really beyond the scope of the class. Now the 6th edition of the book has a really good bonus chapter on time series, which we don't cover. So that'd be a good reference if you want to look into it some more. I'll leave that for the homework. I'm going to post several problems in Blackboard on forecasting. I want you to read Chapter 2, do the assignment in Excel. It shouldn't take you more than 10 or 15 minutes. Make sure the assignments, all 5 of them that you turn in, are easy to read. If they're hard to read, I'm going to have a hard time grading it, and your grade will suffer. If everything's there, looks good, looks neat, I'm not going to nitpick points on it because I'm grading 40 of you. You can either submit it probably in Word, so just copy from Excel to Word, put it all in one Word document, put the one Word document in Blackboard. That'd probably be the easiest. Homework's due in 2 batches immediately before the test. I wanted to talk about one final thing. All of you have had statistics, correct? So you know how to do a linear regression. Yes? Well, if you haven't, it's not required for the test. This is really bonus material. Time series never do a linear regression, okay? Because a lot of time series are going to kind of have some autocorrelation. Okay? Look kind of like that, okay? There's no trend, but maybe we did well last week, we did well next week, we did well next week, and then we start doing bad, okay? So we're just bouncing around happily in here. Now, let's pretend that I start looking here, and I stop looking here, and I run a linear regression. What's my linear regression going to do? What would a linear regression through those data points look like? Draw a line through those points. So you'd be predicting you would go to 0 fairly quickly, right? What would a linear regression through the next 5 points do? So if you're predicting the future and you have time series data, don't use linear regression, okay? It's kind of like someone putting their hands on the chalkboard. Just very annoying. And you'll probably get a very, very bad forecast. And the reason is that a lot of these processes, remember where you were last week? So you may be up a little this week, but you remember where you started, right? It has some memory. And so you may be up a little more, and then go down a little, down a little, down a little. So last week's does impact next week's, but it's, the odds of getting 4 weeks up in a row might be the same as randomly flipping a coin 4 times, which is what? 50, quarter, an eighth, 16th, right? Getting 4 heads in a row, which is still pretty, not that uncommon, right? And when you fit that linear regression line, it's going to just not work well. Any questions about today? Okay. Forecasting is not a big topic in this course. There'll be a few test questions. It's where we start, right? Because if we're going to plan a production schedule, we need to know how much we need to make, right? And then you build off that forecast all of your schedule. So it is an important topic in that respect. I guess today's a 45-minute lecture. I, unlike a lot of professors, when I'm done with my material, I put my pen down and dismiss the class. So hopefully no complaints. And those at home, everything will be posted on Blackboard. Make sure to submit the assignment before the test and keep up with your homework. Have a good day.